All right, we're on page 3 of the solutions. Which diagram best represents the shape and direction of this series of waves after they have passed through an opening in a barrier? This is the phenomenon called diffraction, which is the bending of a wave around an obstacle or through an opening. So in this case, sort of this, you just have to memorize the solution, but the idea of this is as the wave passes through, it spreads out in every direction as it goes through there. So that's where that picture comes from. This one's close, but the arrows are just in the wrong direction. You're going to kind of always see a picture like this on a waves test. It's just memorize it, I guess, is the best answer I can give you. There's a reason behind it, and it has to do with something called Huygens principle, which basically says that there's a bunch of little tiny wavelets, sources of waves on here. So little tiny wave sources. And what happens is that when they get to there, you get that. And actually what you would see in this case would be a combination of the two, which would look a lot like that 2-point interference drawing that we drew. But don't worry too much about that. Two waves having the same amplitude or the same medium, maximum destructive interference. So we talked about this in the last video. Destructive interference is when you have one wave like that and another like that. They are 180 degrees out of phase. If you remember, like a standard wave, if this is 0, this is 90, this is 180, and this is 270, 360 or 0 because it starts over again. So 180 degrees is half of a wave. So when they're a half of a wave out of phase, they're going to be upside down compared to each other. And when you add the two together, they cancel. So that answer was 180. Two pulses in the same medium approach each other. When they meet in the middle, you're going to get a bigger pulse. So that's that one. Basically, you just add. If one of these pulses actually was not on the top, but it was on the bottom when they met in the middle, then you would get, then you would get this answer. But it's not on the bottom. All right, wave X travels eastward with a frequency F and amplitude A. Wave Y, traveling in the same medium, intersects with wave X and produces a standing wave. So standing waves come about because you have one wave traveling in this direction, and you have the identical wave, which is awful, traveling in that direction. And they interfere with each other. And what happens is like our standard drawing of it is kind of this shape here, where this is just vibrating back and forth, and it looks like it's standing still, and these points are not moving. Those are called the nodes, if you remember, and these are called the antinodes. So, which statement about wave Y is correct? Y must have a frequency of, sheet and look at my sheet here, I can't read this. Frequency of 3F, no, it's going to have the same wave, so it's going to have the same frequency and the same amplitude. So I think the answer would be D. All right, a couple more questions and we'll go on to the last video. What type of wave phenomenon occurs when vibration in one object causes vibration in a second? So this is that sympathetic vibration that I talked about. This is resonance. We talked about it in the context of a tuning fork in the back of the room vibrating because one in the front of the room was vibrating. We talked about it in terms of an opera singer, hitting a certain pitch and breaking this glass because the natural frequency here matches the frequency of the voice. So all those are examples of resonance. The last question. Diagram below represents a transverse wave moving in a uniform rope with point A labeled as shown on the diagram. Mark an X that's 180 degrees out of phase. So this is actually not an easy one to draw. So let me show you where 360 degrees is. So if I follow this, right there, is 360 degrees. Okay, so 180 degrees is the halfway point of that. So it looks like it's right around there. So I would put my X right there. Again, it would have been easier if A was right here. You could have just picked there. So whatever this distance is here, this distance should be the same. Okay, hope this helps. We have one more to go. Chase, good comments.